I think you can hear me okay, and hopefully you can see my screen now. Okay, let
I
me
can
know.
see it fine.
Okay, good.
Looks good,
Uh,
Blake.
so thanks again for that introduction. You can see a few that I captured with a free imaging rig in Halifax. That there's a couple of double stars in there, maybe a whole bunch. But the ones I was trying to image were that really tight pair in the middle, but that's kind of looking like a triple. You know, it kind of looks like a snowman shape. And you can see just below and left here that there's a couple of stars really close together, and they've got some different colors on them. So I'm fascinated with double stars. I have been for a long time. Don't get me wrong, I like galaxies. I like planets. I like looking at lots of different things. But when the moon's out or I'm stuck in the city, lots of us are uh, kind of cooped up in our backyard or only have our driveway to observe from. You might think that, wow, there's nothing I can do if the moon's out, or I can't do anything in the city limits, and hopefully I can convince you otherwise. This has been something I've been pretty sort of passionate about for a long time, and it was partly because I started to notice things. I first did this presentation a few years ago, and there were some interesting things going on. Some of them have changed now, but one of the things that seemed to be sort of odd to me was that in our monthly meetings, the RASC Toronto Centre monthly meetings, there didn't seem to be frequent talks or mention of double stars. We usually have once a month a Sky This Month presentation, and people are talking about the constellations that are visible now and what's going on with the planets, and some people are specialized. There's usually some mention of variable stars. Lots of people talk about asteroid occultations, which are frankly not easy, but there didn't seem to be a lot of mention of double stars in those talks. When I did the Sky This Month presentations, I would try to talk about everything, including doubles. At the time, there was not a double star observing certificate program with RASC. We have lots of programs, over a half dozen on the Messiers, of course, and there's something called the Finest NGCs, and there's a couple of lunar programs. To be fair, there's a primer certificate observing program called Explore the Universe, and it's got a good sampler of kind of everything, including a few double stars. So that's good. I'm happy about that. But there wasn't a dedicated double star observing program, not like the Astronomical League. They have a few. I'll talk about those later. So there was some stuff sort of missing, and I started beating the drum more and more about this to generate interest, create a buzz, and now happily we do have a double star observing certificate program. And I also was advocating this at education and public outreach events where you want to be careful if you're doing an observing session or a city star party and you're inside city limits. You want to be careful if you show a galaxy to the civilian, to the newbie, to just an enthusiast, not a serious amateur like a lot of us. They'll just see a wispy cloud. They don't know what they're looking at. So double stars at star parties, those are like low hanging fruit. They're eye candy. People love them. They're fascinated by them. You'll get lots of questions about that. So I was advocating that too. They should be a target or a class of targets that we show the public. So again, it's sort of been getting better. Um, do, do you have me again?
Like, I'm sorry. Oh, yeah. You were muted, it looked like somehow. but you're back now.
So I was just saying that I like this image because it shows a sampler of the kind of variety of double stars that you'll get. There's some that are equal. They're often different colors. You get big differences in brightness. You'll get triples, you'll get quadruples, everything and anything. They work in binoculars. They work in telescopes. So now I have to be careful here or explain something, but I don't want to go sort of off the deep end here about terminology. When I started observing these, I was trying to find a nice, good way to describe these. Double didn't seem to fit right for a lot of the things that I was seeing. I was seeing triples and quadruple systems and so on. So for a long time, I was saying I'm going to observe double stars and multi-star systems, but even that's kind of clunky. So I think I've sort of reached a point. I think I've discovered that a lot of people quickly just use the term doubles to refer to everything, the whole class of these things. But I'm going to show you, or we'll talk about that there are triples and quadruples and multi-star systems and quinvigan-upple systems. So there's sort of everything and anything in between. But I think a lot of people just describe all of these as doubles. Okay, so I'll try to use just that term. So what is a double star? I think that a lot of people have a pretty clear idea what they are. They're when you get two stars that are quite bright compared to the field stars that are tantalizingly close together, and there's kind of a sweet spot. Two stars close together are really sort of eye-catching, and when they're different colors or different brightnesses, it's usually really evocative. But here's an obvious one. There's Albireo that I'm sure a lot of you have seen in Cygnus. So nice yellow orangey sort of star compared to a blue star. Simple double, for lack of a better term. But you can get definitely groups of stars or multi-star systems, but I call this a double. I was actually trying to photograph Otto Struve 457. It's in Andromeda. And you can see in the middle, I hope you can see in the middle, that there's two stars kind of just touching each other. It looks like a figure eight. But I learned when I did a bit of research about this that in fact it was a 10-star system. There were lots of elements in it. A common convention that's used for double stars is that the brightest one gets the capital letter A, second brightest one is B, third brightest one is C, and so on. But you can see in this image that C is not nearly as bright as the F star is. So the naming convention that's been used here is kind of breaking this rule. And you do see that often in many sort of cases. But when I imaged this, I found that, or I learned that there were lots of stars, and I tried to identify them all. And I don't know if you can see it. I can barely see the Y star in there, and I don't know where the G is in this image, in this scaled down image, but I was able to find a bunch of the stars in that. So I like sort of hunting for all the additional components or members, but it does then beg the question, what about this one? Why is that not included? And what about the one above here? Why is that not included? So sometimes there's no rhyme or reason to what's going on with these. But this system, and if you've looked at the trapezium in the middle of the Orion Nebula, you know that a lot of times there's groupings of 4, 5, 6 stars or more. And then you can get in a really extreme situation. Blake, here. Yes.
I'm sorry, is it okay to ask questions, or should we say, can I ask a question now?
Sure, I think we can take it now, sure.
So in the previous one, when you said, like, why isn't that star included? Could it be because, are these ones that are lettered actually in gravitational togetherness, and maybe that other one is a far off star that's not part of the gravitational system? Could that be the case, or? No.
It's a good question, Sandra, and my answer is maybe. I'm sorry, that's not a great answer. But I suspect that when these stars were all identified, there was no known information about their distances. But let me come back to that. That is a factor about what we're observing here. But that's not been my impression for the naming of these stars and what's included and not included. I think it's the whim of the discoverer. And often double stars are viewed by multiple discoverers, so they tend to grow. That is, more members get added. Now that's partly as our telescopes get better and we go deeper and see fainter things that you'll see that more accumulate. But it's a great question, and it's difficult to know.
Thank you, Blake.
Here's the 37 cluster that you may have observed. That's a well-known open cluster, NGC 2169, in the Orion constellation. And I imaged that and sort of flipped it around so it's the right sort of way. But I learned that it's also considered a multi-star system. It's listed in the official catalog. The Washington Double Star Database, or the WDS, includes this as Struve 848, and it's a 20-member system. So often when you look in an open cluster, you'll often see pairs. They're very obvious pairs, but maybe a whole bunch of the stars, the brightest stars in that open cluster, are also considered a multi-star system. So that's the sort of extreme thing. I think the most sort of rich double star that I've seen had 24 members in it. So it's kind of fascinating. And they're going to run out of 26 letters soon. So maybe, I don't know what they're going to do, AAAB, kind of like Excel spreadsheets or something like that. I don't know. So anyway, we can get some neat examples from simple pairs. There's a lot of triples and quads, and then you can get big sort of groupings here. Now, Sandra's question a moment ago was really, really good. When you look through the telescope and you see a pair of stars that are really, really close together, you have no idea what's going on. You can't know that unless you had some materials or some research information beside you, or a catalog open, or you were actively searching the Washington Double Star Database. But a lot of times we'll see stars and they appear really close together in the eyepiece, but they could be really far apart in space, right? So let's say that A star is, I don't know, 1,000 light years from the Earth. No, let's make it 10,000. 10,000 light years from the Earth. And then B is double that. So if we're talking about those kinds of distances, that's in different parts of the galaxy. They're clearly not related. They're not affecting one another in a direct way. Yes, everything's connected, but two stars that are 10,000 light years apart are not directly affecting one another. So there's no sort of gravitational effect. There's no sort of direct relationship. And I think Alberio is one of these, that we've been studying this for a long time, and the jury's still out. People are still actively doing research on that, but the prevailing sort of information seems to be that those two stars are not related. And what is really telling is if you can get the measurement, the distance measurement for each star independently. Some people will say that these types of double stars, optical double stars, are of no interest. Don't bother looking at them. They don't mean anything scientifically. They don't tell us anything. And I still like them. I'm not discriminatory. I don't care what kind of double star system it is. Here, I just enjoy the view. And I think you can get probably some really interesting color combinations and brightness effects here, where the stars, maybe because they're not related, they'll often be different colors, different ages, different compositions. And I've shown it here where the A star is brighter by proximity. I'm suggesting that, but often you can get some major differences in brightness, and it might be because of the extraordinary distance between them. You can get stars, let's imagine for a moment that the A is, much closer to the B. Let's say it's over here somewhere. And maybe they're 1 light year apart or 5 light years apart. And you'll often find that in open clusters. I was just reading some research from the European Space Agency today, data ascertained from the Gaia probe that we're finding lots of strings, sort of these running sort of strings or lines of stars that are moving through the galaxy. So stars that are quite close together, they may be described as a physical system. If they're in an open cluster and they're moving through space together, like dolphins in a pod following a ship, they're called physical, even though they're not touching one another. And you can often determine that by even before the Gaia space probe by looking at proper motion. The other end of the spectrum, though, no pun intended here, is when we get stars that are so close together that we switch to astronomical units. That if we've got stars that are 20, 30, 50, 100 astronomical units apart, very likely one of those stars will be orbiting another one. That there's a primary, and then the secondary star is orbiting the primary one. I'm showing the famous double star or part of it in Gemini, and you can see that the B star in 1970 was kind of at this angle here. What is that? Maybe, I don't know, 1 o'clock position or 2 o'clock. Oh, I have my cardinal points here, so it's to the southeast. But where would it be today? Maybe around here. It's going to be around here. So now the direction is this way. So now it's to the northeast. So again, looking through the telescope at a pair of stars, you don't know what's going on at that snapshot, at that moment in time. But if we repeatedly view a pair of stars and we start to see that one of them is moving in relation to the other, and with relatively few data points, if we start to see a curved path and we calculate the arc or the path of that, get a preliminary orbit, we can surmise that it's likely a binary system. So binary is generally reserved. That word is used for the specific circumstance where you have a star orbiting another star. Doubles I use as a general category for everything, but binary is a subclass where we have orbital elements here. And that's pretty neat. That's sort of significant scientifically. And you know what? You and I can study these. If you measure a double star, you measure its angle in relation to the primary star, and you measure the distance from it, and you collect that information, do good data reduction, and submit a paper on that. You're contributing, you're doing citizen science, you're contributing to our body of knowledge on double stars. Anybody can do it. You can do it in your backyard. The same way that people do variable star measurements, basically the same approach there. So that's pretty neat. Now you can see Castor B has a long period here. We're getting into centuries. I like looking at a lot of fast movers, a lot of fast period binary stars. I watch them every year. I'll take photographs, every year. And some of them have periods that are 50 years or 100 years. So that's sort of neat. You can see some of these stars moving. So I like looking at all types of double stars. I'm not picky again. And it's neat knowing that you're seeing some binaries out there. Some lists or catalogs that you look at will tell you the type of system, if it's optical, if it's binary, if it's physical, or sometimes we don't know. There's actually a good number of doubles we don't know anything about them. So we have to keep looking at them. I really like looking at double stars because we see real color. Again, if we look through our telescope visually and we see a galaxy, it's probably just gray. It's still great. It's a great view, but it's just this gray fuzzy object. And diffuse nebula, same sort of thing. If we're lucky, a planetary nebula might reveal a little bit of color to us. But you look at any double star and you'll see lots of color usually. not the colors, you know, on the Earth. Sissy Hawes, uh, an author of a popular double star book, she says they're more attractive than the flowers on Earth, double stars. We don't get greens or purples. This is all black body radiation stuff. But we know that if you know your spectral class, we know that O class stars are blue, white, hot stars, whereas at the other end we have M class and K class stars that are cooler and red or orange in their color. Uh, Ignore the sizes here. We know when we look through a telescope that every star is a point source. It's just the smallest point that you can sort of perceive. But imagine an O class star or a B beside a K or an N. You can get this amazing color contrast. And again, you can see this. It's real color. You can detect it with your eyes. And again, if you show this at a public star party, people will go, "Wow, that's amazing! Look at those colors. Where's the color coming from?" And you can talk about, you know, stellar classes and surface temperature and composition and things like that. So it's really, really neat. Sometimes you get two stars, maybe a G and an F class, and you're staring at it for the longest time, going, "Which one is it? The one on the left that's a bit more orange? I think so, and the other one's just white, I think." So that's fun. I really like the colors of double stars. Of course, it's all very subjective here, but that's a cool thing. And that when we are able to observe together, I like being able to hit a double star and then say to people, "Hey, check this out," and I ask them their impression. I do that at public star parties. What do you think? What are your impressions of the color? So it's fun sort of comparing notes. But it gives a jewel-like quality to the star. Now, a fun and sometimes challenging part of double star observing is that the stars can be very close together. When you look at stars at low power, maybe with binoculars, stars might be so close together that they merge or they touch. But if you have a telescope, you've got a few eyepieces in your kit, if you can bump up the magnification, you can get stars moving apart. And when they move apart and you can split them, when you can get a black line between them, that's really great. Now, a lot of times I'm not successful at that. And don't think, you know, there's no prize at the end of this. Don't think that you have to split every double star that you look at. There's a lot of times where I'm looking at it out of season, I'm too early or too late, it's really low, I'm looking through bad seeing, I'm from my backyard, I'm looking over top of the neighbor's rooftop and it goes through the plume from the chimney. So momentary, really bad seeing. So a lot of times it goes into my log notes. You're supposed to keep log notes, right? So it goes into my log notes. Could not split this star at this date. The conditions were not great. Seeing was terrible. I'll try again. So I have a view again list where there's a lot of double stars that I go after again when it's near the meridian, when I have hopefully better skies. So I like that. Of course, everything's measured in angular scale or measurement. So degrees, arc degrees, arc minutes, arc seconds. And all double stars generally are sort of measured by arc seconds, even binocular double stars. So it might be 200 arc seconds or 220 arc seconds or something like that. But if you are keeping log notes, these are common terms that people use, like touching or figure 8 or peanut and rod shaped and stuff like that. Now, a big thing that affects your ability to separate the double stars, in addition to the seeing conditions and the collimation of your telescope, is the difference in brightness. I'm showing stars that are equal, but if you get stars that are very, very different in their brightness, that can make it more challenging. Do you see it? You see it right there? That teeny weeny little tiny dim star, that little baby star. I shouldn't say baby because that suggests age, or it suggests that it's small. I have no idea what the sizes of those stars are, but one is clearly more luminous than the other, and the other one is very dim compared to that.
But I love looking at doubles that are like that. You know, you look, your first impression is, oh, I only see one star. Hold the phone. There's a little tiny faint one, you know, just at the edge of the glare. It's almost washed out. And again, if you start throwing more magnification at this, you bump up the power, you get those stars moving apart, and maybe you more easily see that faint star. Uh, faint stars might be lost in a washed out sky. So there is the whole aspect of just sort of what your sky limiting magnitude is and what your optical equipment limiting magnitude is. But that's something I really like about double star. Again, it speaks to the variety. You get all these colors. They can be very close or very far apart, and you can get tremendous delta in the magnitude, extraordinary differences in the magnitude. So it just makes for all these different scenarios. That's Sulafat, by the way, in Lyra. That reminds me of Sirius. I've been trying for years to see Sirius B, and now is the time, because Sirius B is a binary. It's orbiting around Sirius A, the primary, and it's at maximum separation kind of over the next few years. So I keep trying to go for it. I tried this winter and I couldn't see it, but I'm expecting to see something like this. I just need perfect conditions to be able to see it. Okay, so what do you need to view double stars? You need more telescopes. Okay, maybe not. I always tell people, run what you brung. So it doesn't matter what you have. The 85%, that's my reminder to you for something that's in the RASC Observer's Handbook. The opening paragraph in the first double star article there says that when we view stars under magnification, 85% of the stars will appear as doubles or triple stars or multi-star systems. Okay, so lots of stars, when we can magnify them, appear as multi-star systems. With just your eyes, if you have perfect vision or you got a good prescription and you were in perfect dark skies, in theory, you could see 3,000 stars. If you have binoculars, you see the binoculars in the middle of that cornucopia of equipment there. Binoculars would, even 7x50 binoculars should let you see theoretically 150,000 stars times 85%. So you have a boatload of doubles that you can look at with binoculars. You don't need really sort of special equipment. You're into the thousands or tens of thousands of double stars easily viewed with binoculars. If you have a telescope, and presumably you've got a couple of eyepieces, now you're into tens of thousands or more of double stars. There's so many double stars, you will not run out. You will never run out of objects to look at. So that's pretty neat. Speaking of eyepieces, you should use all of them. I always start at low power and see what I see. My first impression might be, oh, one star. Then I'll bump it up. I go, aha, I see 2 stars. That bright point is splitting into 2 stars. And I increase the magnification again. I go, aha, there's 2 stars. Hey, there's another one. So it's a triple, and there was a little faint one beside it. Then I'll walk back down in the magnification. I'll go back to my lowest power, and usually I can see everything at that stage. It wasn't obvious to me at first, but now I know where they are and what the colors are. So that's neat. I'm up and down in my eyepiece collection. You know, when people are starting into the hobby and we tell them, don't buy telescopes at the department store, and be careful of the claims on the box that say you can go to 600 times magnification. We always tell people you can't do that. That's bad sort of advice. But with doubles, you get to break those rules. You can go 300, 400, 500 power. A lot of times I do that to coax out a tight pair or to get a faint. So you can do outrageous magnification and then back down to your low power. I am so, in some cases, up and down the eyepieces so much, I want to actually get a nice zoom eyepiece so I can stop fiddling with all the gear and keep the dew strap on one eyepiece, and that's it. So if you got a nice zoom eyepiece, use that. Start low, zoom up. When can you observe double stars? I have good news for you. Anytime, even if the moon's out. So that's really nice. You can see here on the Tuesday night clear sky chart here, it's crummy here. And oh, the Wednesday night, it's clearing up at 10 o'clock and the transparency, so, and the moon's out. So no galaxies, no nebula, but this is double star time. So that's pretty good. And the seeing conditions, ideally you want really good seeing. I don't sit around and wait for good seeing, but I make a note of it. And it can change through the evening. But I can see the seeing here on the Wednesday night is average. It's not great on Thursday night. The seeing is poor, but it gets better at 1. So now it's more moony. We're getting close to the full moon phase, but still a lot of times I see it's clear out and the moon's out, but I go, okay, we're doing double stars tonight. And I take it in terms of seeing conditions. Where can you observe? Anywhere, if that's not already obvious, even in the city limits. We're talking about point sources. We're talking about beams of light, photons, and that punches through light pollution. So you can look in your backyard, you can look from your driveway. Obviously, you don't want to be too close to street lights. You shouldn't look right over the edge of the neighbor's house. If it was hot in the daytime, you'll get artificial seeing there, and watch out for chimneys and stuff like that. But that's cool, especially now when we're stuck at home. You can observe double stars anywhere. If you have a go-to scope and you've been able to align it sort of well, you're good to go. Admittedly, if you have a bright sky and you're star hopping, that part's hard. But once you've found your target, you're going to have a good view of a double star. So that's really nice. Where can you get lists for double stars? I have a lot of suggestions for you here. To toot my own horn here a little bit, we have the RASC Observer's Handbook. There are 2 lists in it. The first one, double stars and multiple stars, with over 135 entries in it. There's actually 2 columns, and they show the position angle and separation for last year, and then the position angle and separation for this year. Those are binaries. We're showing that they're moving. They're usually close though. Those are more challenging. So if you're looking for fun stuff, eye candy, do the other list, the colorful doubles. There's 100+ entries in there. They're really good. There's a US edition of the Observer's Handbook, by the way. And you go to RASC.ca handbook and see those books are by. Now RASC has a double star observing program. Yay. And there's 110 objects on that. If a member pursues this and they want to get the certificate, they just need to do the 110 and they're done. There is a supplement though that comes with the program, and it shows that many of the double targets are actually triples or quads. And I don't know how many total are on the list, but it might be around 200. So there's tons of targets there that you could pursue. Again, there's the website for that, note the hyphen in that, or just go to rasc.ca and you can find everything there. Magazines, they all sort of promote or encourage double star observing. Sky and Telescope, I think they've got a number of people that are really keen about doubles. So, and that's how I got started actually. I took their summer list and printed it out. I took their winter list, printed it out, and I was literally checking off the boxes there, going through all those. I think I've seen essentially all of them from those lists. And usually in each magazine, each periodical, they've got an article about double star observing. They actually contacted me back in 2017. They were writing up an article on binocular doubles in Draco, and they wanted one of my photos. So I gave them the Omicron Draconis photo, and I was really honored to be asked about that. About this, the evening sky map is something I often encourage beginners to check out, or just interested people at star parties. But what I like most about this is page 2, that has the list broken down by what you can see with different equipment, your eye, with binoculars, or with a telescope. And there's doubles in each one of those. So that's pretty cool. That's a good list. Now, I mentioned the Astronomical League before. They actually have 3 observing programs. They have a basic program for binoculars, and it's got 120 objects on it. Those are candidates, and to complete the certificate, you just need to observe at least 50 of those. They have an advanced binocular program. They have 100 candidates, 50 are required. They have a telescopic program, 100 objects, you have to view all 100. And you have to provide your log notes, of course, and you have to do sketches for each one of those targets. Now, some people, that puts them off. They go, oh, I can't draw, I can't sketch. But arguably, a double star sketch is one of the easy ones to do. Do your field of view circle and do 2 dots. And you're done. It maybe put some field stars in, note your direction and other details. That's a good sketch. There's great paper resources if you prefer that. Arguably the most popular book on double stars, I mentioned Sissy Haas before, double stars for small telescopes, and it has over 2,000 entries in it. Mine's dog-eared, and I've got lots of notes in it, and lots of check marks in the left column for all the targets that I've seen. And I don't go through her book sort of start to finish, and there's a lot of constellation. She has all the constellations, so there's ones in the southern hemisphere I've never seen. But for my own personal log history, I think I've seen now 1,600 or 1,700 double stars. I haven't split all those, but that's what I've tried. If you like atlases, get the Cambridge Atlas of Double Stars. Of course, it features charts by Will Tyrion. He's amazing. His charts are fantastic. And the second edition, which I strongly recommend, is edited by Bruce McAvoy. And he is amazing, has this incredible website, really, really good information about double stars for the casual observer and some really heavy scientific stuff as well. Lots of double star paper charts will show doubles as a disc or a circle with a stroke or a line through it. So they look like little Saturns or little lollipops. So there's all the double stars, Aimnear, Theta and Eta. These stars here in Scorpius, and you'll see a bunch of doubles in your field of view. So that's pretty neat. Now I haven't used paper charts for years. I'm using software. If you have Stellarium, if you have Sky Safari, whatever you have in terms of computer software or apps, you point to a star, select it, and zoom in. The star will break apart into 2 stars, which is not unlike what you would experience if you start at low power in your telescope and keep increasing the magnification. I'm a big fan of SkyTools, the planing software application. AstroPlaner is also very good, and they have really good information about double stars. Here you can see I've zoomed in really closely to a double star, and I took the snapshot from SkyTools where I had it plot the orbit. So that helps me figure out where the star is or where it should be at a given time. So SkyTools is really good about its double star information. It's not perfect, but it's very, very good. The Cloudy Nights site, of course, all the forums there are amazing. They're really, really good. But there's a very active community of people in the double star observing section. I pop in every once in a while, people all around the world. There's lists, recommendations for books, new book reviews. People post their observations. People post their split limits. You can see there's a post here about your sub-arc second. And that's my career history. I'm around 0.9 or 1.0 arc seconds. That's the lowest I've been able to go.
Hey, Blake, do you see the post at the bottom?
The question?
Could you go back one, please? Did you notice the post at the bottom of that?
Oh, yes, I did. Yeah.
Okay, good. That's us.
Thank you.
So I had to point that out. Thanks.
That was cool. Yeah. A little heads up here about designations of double stars. A lot of double stars were found by the discoverer Frederick Struve. And those stars are often marked with an uppercase sigma. And when a software tool or a chart wasn't using the Greek letters, we'll see the code, the 3-letter code STF. Family relation, Otto Struve, his double stars are marked with O, uppercase sigma, or STT, stot is how I sort of refer to it. These observers, plus a few others, were very active in sort of the golden age of double star astronomy. A lot of work done in the 1800s and early 1900s. William Herschel stars are marked with H or HN. He has some subclasses of them. It was actually Herschel that repeatedly observed stars and found out of a large grouping of a large sample that 50 of them were moving in curved paths. So he was one of the first to substantiate what was not well understood at the time. You've got stars orbiting around other stars. Henry Draper stars, HDs, there's a lot of doubles there. The big one I want to caution you about is Burnham. Burnham double stars are sometimes noted with beta. Don't confuse that with the Bayer classification for stars in a constellation. Beta, followed immediately by numbers, is a Burnham double star. Beta by itself is the second brightest star in a constellation. So watch out for the beta reference. If the letter code is used, it's not ambiguous, it's BU. I mentioned the Washington Double Star Database before. That's the official catalog or database or warehouse of all that information. That's maintained by the US Naval Observatory. But the USNL websites are under maintenance right now. So if you're looking for the WDS database, it's currently hosted at the Georgia State University. So head over there to find it. There are over 150,000 records in that database for the main pair. And then there's associated observations. There's multiple observations for many stars. And if you were to go through that, they used to have a separate segregated neglected double star list. But if you go through that, you will find that many double stars haven't been observed for a long time. So there's a lot of need. Professional astronomers want amateurs to help fill in missing data and update this database. So again, citizen science can be done here very easy. I've been encouraging you to keep log notes. You should be doing that, or I strongly recommend it. But you can see here somebody's double star log, and you can see some doubles are plotted here. You can see the diffraction spike from their Newtonian. My log notes, I describe colors and the angles. Sometimes I just use the clock face. If I know where my north and west is, I'll note that. And a lot of my log notes say could not split. So again, that's not something that we have to do, but I note the conditions and then I designate it to view it again. Here's a few suggestions. Some of these are off limits right now, they're winter. But, and I've been really enjoying imaging double stars. So I've got a few pictures here. That's my Tsar Alcor at the top left here. I love the colors. See that amazing color difference between those two stars, that orangey red star and that beige one. And these stars, look closely at those, they're not the same color. It looks kind of like car headlights, but they're a little bit different in their magnitude and a little bit different in their color. It's very, very subtle. But that's just fantastic stuff about double stars. All this variety and differences in colors and brightness and doubles and triples and quads and so on and so on. So I really like doubles, obviously. So what do you think? Are you sort of excited? I hope that I've been able to share with you some information about them. Very high level, obviously, but I hope you'll see that they're fun, they're interesting. They can be very easy to observe, but they can also present some challenges to you if you sort of start getting into some of the really tight ones or unbalanced, unequal pairs. But they're really great. Again, they're fantastic targets for public star parties. You'll get these huge, oh wow, look at that, reactions at the eyepiece. So I hope you'll consider adding them to your observing list. Again, when the moon's out and you've been thinking, oh, I can't do anything, get outside and look at double stars. There's lots that you can do. And if you're keeping log notes, keep really good log notes about the colors and the angles and if you could split it or not. And I hope you'll consider showing them or using them at your member events when you get back to the Nature Center. Again, when you're observing together, somebody's looking at a double star, go over and have a look. Or if you're looking at double stars, say, come here, look at this. What do you think those colors are? So they're a lot of fun. So thanks. Thank you for inviting me again and letting me share my interest or passion on double stars. And I hope you'll start splitting them.
Hey,
Thank you.
Blake, yeah, this is John.
Yeah.
For majority of your observing, do you use a refractor? I noticed in your plethora of telescopes there, it looked like there was a teleview in there.
So I have a few different telescopes. My main one is an 8-inch Celestron Schmidt-Cassegrain. So that's my preferred scope to use. Obviously, lots of light grasp. But I have a little Meade 90 millimeter ETX, and that's my grab and go right now. I can be outside in 20 minutes using that scope and tracking with that scope. So I like using that one. I have a 6-inch reflector, an old Edmund Scientific. It works really, really well, but it's on a big, heavy equatorial mount. So I'm repurposing that and putting it into a Dobsonian base. So that'll become my new go-to. When I'm up at our club observatory at the Carr Astronomical Observatory on the Blue Mountains near Collingwood in Ontario, just off Georgian Bay, I'm spoiled. I'm a supervisor there, so I have the run of the equipment. So we've got a 16-inch RC telescope there. We have an 8-inch RC imaging scope. And when the crowd leaves and goes home, this is at our old public events. We haven't done that for a year, of course, but when I'm at the David Dunlap Observatory, I've got a somewhat large 74-inch telescope to play around with. I do have a refractor, but I don't have a good mount for it, so I haven't even used that yet. So everything and anything.
Yeah. Okay.
Blake, I wonder, in our discussion the other day, you kind of reviewed the eyepiece opportunities, those which have the calibrated. I wondered if you could show those slides, just have a brief overview of how to use those.
Sure. Give me a minute. I'll open up another presentation. I did kind of a two-part presentation for the Royal Astronomical Society Toronto Centre people a few years ago. Where did I put that? Let me just track that down. So the part 2 presentation that I did was on doing measurement kind of formally, but doing that as sort of inexpensively as possible. So a way to do that is with a pretty easy way to get into this is with a calibrated eyepiece. Let me just show. There it is. That's what you meant, Bob, right?
That's correct. Yeah.
So if you wanted to measure double stars and you just wanted to spend a couple $100 sort of to get started on it, or less, you could get a Meade astrometric eyepiece, and it's a 12 millimeter eyepiece. I think it's orthoscopic design. I'm not 100% sure.
Oh, yeah.
And it's got this stalk off the side of it, and that's got an illuminator and batteries and a switch in it. And when you turn on the illuminator, you can see this etched reticle inside of it. You can see it's got a linear scale that's got 50 divisions on it. You can see there's a big circle around the outside. The large circular thing is marked with degrees, of course. And we have a half protractor here as well. So that makes it easy to measure things too. That crosshair in the middle is what people used in the old days for manual guiding. Anybody do that anymore? So that's sort of rare, but it can be used to help you with, an eyepiece like this can be used to measure the distance between moons, say around Jupiter, or to measure the size of a planet. But it's easy to measure the distance between stars and get their angles here. So that's the Meade one. And we were looking that up the other day, and I think we were seeing prices less than $100, I think. So it's pretty inexpensive, that one. Now I have the CELESTRON unit, and I went looking for the CELESTRON online to see how much it would be, and I couldn't find it anywhere. Most stores show it as out of stock or discontinued. So I was getting really nervous. Can you not get these anymore? But then I found when I went to the BAADER website, you may have BAADER eyepieces. I have a couple. The BAADER company makes this. And as soon as I saw the picture, I went, wait a minute, that's the same as the CELESTRON one. And then I realized really what happened, that CELESTRON never made it. They contracted BAADER and just badged it as a CELESTRON. So the BAADER or the CELESTRON microbad is a 12.5 mil eyepiece, same sort of deal. It's got this stalk that sticks in the side of it. You can see the illuminator in this case. And there's the reticule inside there, slightly different. It's got two lines. It's marked with 60-degree division, so a tiny bit more granular. It's got the large circular pattern, and it's got degree measurements, except they go clockwise and counterclockwise. And I like that, actually. I prefer that. So I have the CELESTRON / BAADER micro guide, and I've used that to measure double stars. And I first read a couple of articles on the Sky and Telescope website about how to use it, and I sort of practiced those methods and got pretty experienced with it. Now I do it all with my camera. I do imaging, I do drift timing and stuff like that. But this is an easy way to get into it. You can do quite accurate measurement with this if you use sort of an advanced, refined method. So that's an easy way to get started. For the serious astronomer who wants to do some of that citizen science, they can do it with either of these two eyepieces. I've looked for do-it-yourself sort of solutions for this, and I haven't really found any. I'm a real do-it-yourselfer hacker. I've tried to figure out if there's a way to do this, without something like this, and I haven't found any really good sort of tricks for that. To toot my horn here, here's the RASC website. There's the double star page, lots of information about the program, but anybody can download the observing list. I've made that available in PDF form, and I've also made electronic versions of the observing list. So if you have SkyTools, Sky Safari, Stellarium, if you just want to load it into a spreadsheet, that gives you an observing list that you can work with. And again, there's 110 entries there. The supplement has all 110 entries on it, plus all the additional stars with the main 110. So again, there's quads, there's quintuple systems, and so on. And there's the Washington Double Star Database. I'm at the Georgia State University, and there's the catalog. What's it as at right now? 154,000 entries as of Wednesday the 14th. So lots of double stars. And again, a lot of those are incomplete. We need more information for those. So I'm starting to measure lots of double stars and starting to submit my findings and stuff like that.
Cool.
In one of those pictures, I was going to point it out here. Where was it? Yeah. When we were looking at the 37, this is the eye-catching thing here, right? But if those are all considered members of a double star system, what about this? What about that little pair there? That looks like a double to me, equal stars, almost equal. Well, what about what's going on over here, this double here? See that? So that if these are doubles, why not these? And do you see this one here? Can you see it? You got to look really closely. That little tiny faint equal pair. Do you see that?
Yes.
Double star revealed in a photograph. I don't think any of those are in the catalog. You with me? So this means if you're looking at some double stars one night visually, and you could measure them with an astrometric eyepiece, or you photograph something and you go, hey, there's a bunch of doubles over here. I wonder if they're in the catalog. You'll find that there's lots and lots that are not in the catalog. So you could measure them, you could submit that. So that's sort of neat. They're fun to look at, but I'm starting to move into the sort of the research, analyzing, measuring. Last summer, I was in the backyard in June, and I was just casually observing. And I went to look at Vesta, I think it was, that was going through the Pecula. And I was watching it night over night, and I was sort of watching how it moved and stuff like that. And I often sketch when an asteroid is moving. So that was just for fun. It just happened to be one of the objects that was visible in that evening. But then I noticed as I'm looking there, I'm seeing lots of double stars. So I'm checking my software, and it's telling me about a few of them, but I saw way more than what my software was telling me. So the next night, I set up an imaging run, and I shot the whole region. I did a mosaic with about 12 shots in the panel. And then I did another imaging run, and I've been going through trying to classify all the doubles that are in that area that are not in the catalog. And I can't believe this, but I think I found something on the order of 500 or 600 pairs of stars that are not cataloged. So I actually contacted the manager of the Washington Double Star Database and said, is this possible? That I could have found a whole bunch of doubles like this that aren't cataloged anywhere? And he went, yeah, it's possible. So I've been reducing that data. It's taken forever. So anyway, it shows you anybody can do this.
Have you been able to measure the masses or the reduced mass of some of these systems with some of the measurements you've made of double stars?
So I have not taken the measurement work that I've been doing beyond just reporting the separation and the position angles. There's I think I know what the math is. Let me just go to that other slide presentation for a moment, because I do have a really good book for this to point out. Let me just track it down. Where's that book? So I haven't done that. I haven't gone beyond just sort of measuring them. But this is a really good book, Observing and Measuring Double Stars. It's by Bob Argyle.
Argyle, yeah.
You've probably seen him in SkyNews, and it's the second edition. Get the second if you can. And this is filled with essays, and they're about everything and anything. And some of them get into the math. Some of them talk about how to calculate the orbits based on the observation data points that you have. And I believe there's articles there where you can infer the mass, but I think you need spectral classification for the stars to then calculate the mass. So with the orbital data and the spectral class, then you can do the mass calculation. So you've got to do a lot more data collating and crunching to do that. So I'm just doing measures. I get the distances and I get the angles, and I submit that. And presumably then other people sort of take over from there. They use that data or the increasing collection of data with more and more data points to corroborate against spectral classification and so on. And maybe it's done automatically now. Maybe there's machine algorithms or artificial intelligence that look at the data to see if there's a binary system and then begin plotting the paths. I don't know if I have a good, I'll use Sirius as an example. So here's another great website. Stella Doppie. Stella Doppie. It's from Italy. Here, note the spelling of that. Can't read that blue text. That's a bad color. But is the name showing up anywhere here otherwise? But Stella Doppie, I regularly consult this, and it scrapes the data from the Washington Double Star database. But they present it in some really, really useful ways. And you can create an account here to do your own sort of project. But let's try something here. Let's look up Sirius. So lots of data here. So here you can see the pairs, right? A, B, AC, AD. So clearly a multi-star system. And when you choose one of the rows out of the list here, note the pointer. So I'm currently on the first row. So if I click on the second row here, for example, it changes the pointer. And I look at the top information here. The nature of this double is uncertain. So we need to measure it. That means anybody can go with this, look at that AC combination and measure them. And you can see their brightness difference there, 12.2 compared to the -1 star. So that's going to be challenging. It's a 14 delta magnitude. And how close is it to the primary? It's 64.5 arc seconds away. So it should be easy to see that, maybe visually, certainly photographically, should be easy to see that. And we need to get data about it because we don't know if it's a binary or if it's physically related. If I go back to the first one, the AB star, that's the famous Sirius A and B, the pup here. This double is physical. So that means they know that they're connected in some way, gravitationally related in some way. And then I'll scroll down here and they've computed the orbit. So that's a mathematically computed orbit. That's not the data points that have been collected. This is a calculation of where the star should be. You can see why I'm interested in trying to see Sirius A, or rather Sirius B right now, because it's swinging out far. This is the best time to look at it. Not here, but while it's swinging out really far from that, then it will be easier. But I haven't seen it yet. I built a diffraction mask to take some of the energy away from the primary star and divert it. So hopefully, but now I can't see it. So next winter I'll try it again. I'll try my diffraction mask and I'll send the spikes, out at different angles away from where B should be, and that should help me see the B star. And I'll try to photograph it too. So that's a great website. I use this to sort of corroborate things, and it pulls data out of the Washington Double Star database that is otherwise hard to get. In the past, you would have to mail or email requests to see all the additional data. There's all the historical measures. So you can see the rho and the theta, and they're changing. So we know we have a binary there. They also show proper motion. So sometimes you just get stars floating through space, right? So there's proper motion data. We should pay attention to those too. So those are some of the resources I regularly use.
Blake?
Yes.
Oh, I'm sorry. Were you finished? Can I start another question, or
Go
were
ahead.
you finishing something? Okay.
Yeah.
I was just wondering how come, and many people in the public have asked me this, when I look at the double, Epsilon Lyra, and they're like the direction of the two pairs, the largest pairs there are at right angles to each other.
Yeah.
And people have been observing this for like hundreds of years, but it never changes. Is
Right.
it just because it's so big and so far away? Why don't those rotate around each other?
It could be that they're optical. So one's in the foreground,
No,
one's
the
in the back.
double Epsilon Lyras, those are binary systems.
And it could be that the orbital periods are 3,000 years. So Shall we look it up?
It seems like we'd see it move even a little bit, though, if it was 3,000 years. I mean, they're like perfect right angles to each other.
Yeah.
Can we look it up there? Can you?
Yeah, let's see what the current information is. So we've got the AB pair here. So we have orbital data on the AB. So let's emphasize that one, that this is considered a physical double. The double is physical, and we go down, and there's the orbit. And I want you to look at these numbers here. This is Sandra, right?
Yes.
So notice the separation. That's the row column, right? 2.3, 2.3, 2.3, 2.3, 2.3. It's barely changing, right? Over a decade. And when it changes, it goes to 2.2, 2.96, right? It's still 2.3 basically. And look at the theta, that's the position angle. So it's 349, 348, 347, 346. So it is changing. It is moving, but it's slow.
The orbital period looks like it's 1,000 years.
Yeah.
Over 1,000 years.
Yeah. So yeah, there it is there. There's a 1,000-year period. So it is moving, but it's so small that change that we're not seeing anything significant over a short time. So Sandra, keep looking, and 100 years from now, we'll check it again. Okay.
Okay. Thank you. Now I can, at least when people ask me, I can say with confidence that that's the, I always was just guessing. It's just so big and so far away, right? That's the answer you give the public.
Yeah.
And so slow, it's moving slowly.
So tell them it's a very long orbital period, that some double stars appear to have periods that are thousands of years or 2,000 years. So they are moving, but we can't detect it in our lifetime. So what you might want to do is look at this. Let me make the printing bigger here. So I like looking at fast movers. So I have a short list here that I have a couple in each month that I look at. So every month I go look at things. So it's springtime. I always look at Alula Australis or Xi in Ursa Majoris. It has a 60-year period. That's maybe a double star to show people. And then 5 years from now, it's going to be in a markedly different position. Now, most of these are really tight. So that's 1.9. So that's tough. But you can see Procyon is 4 arc seconds. There's Sirius at 10. It's 10 or 12 right now. I wrote my note currently wide. Look at it now. But a lot of these are sub arc second, or like these are challenging targets. But I've got this list, and I keep going back to these. These are so tight that we can't photograph a lot of these, because you need an optical system that has, really high resolution. So I haven't been able to do any research proper at the David Dunlap Observatory, but with the 74-inch that's got this huge long focal length there, maybe I can put my camera on that telescope once every year or so and measure some of these really tight ones. But we can see that you can probably see 1 or 2 arc seconds or a bit less in a regular telescope. So these are things that you could look at. So that's a little side project that I'm just for fun watching these stars orbit around their parent.
Great, thank you so much.
But I think a lot of times the thing that limits the kind of split you can do is the seeing. I mean, to get conditions that are good enough to separate something that's less than an arc second, and I live in Southern California where we get a lot of clear skies, but you don't get sub-arc second seeing hardly at all.
The clear sky charts don't measure that or tell us that, right? I mean, they give us a crude system. The seeing is, you know, out of a scale of 1 to 5 kind of thing. I don't know if you use Good to Stargaze, but Good to Stargaze does show you what the predicted seeing is in arc seconds. So you can see that mine's showing as, you know, 2 for many of the time slots tonight, but after midnight, before dawn, it gets really good. It gets down to 1.2, 1.3, and so on. So that would help. You're right. So the seeing can really interfere with that, and we just can't do that. If you don't like that, launch your telescope into space. Problem solved. So I'll look at that just to see what I'm up against in terms of conditions. But again, that doesn't stop me. This just tells me, oh, you know, if it's going to be 2.0 tonight or higher or worse, then okay, I'm not going to be able to split some of those, you know, 1 second ones or the 1.1s that I wanted to. So I'll try, but I don't have high hopes then. You know how seeing can sometimes, though, just for like a minute,
Yeah.
go rock solid, right? And you're just in the right place at the right time. So we can always hope for that. You're looking, you go, no, this is mush. And then all of a sudden you go, holy smokes, there's 2 stars. There they are. So we kind of never know. And I don't know if you guys have sort of thoughts on aperture. I am, you know, lots of people say bigger apertures are more susceptible to bad seeing. And I don't know, that may be true. But I wonder if that's one of these things that's a bit of mythology and people keep propagating and we just believe it. So I'm actually going to research it. I'm going to see if I can find demonstrable proof of large apertures having or being more susceptible to bad seeing. Lots of people say, oh, you got to use a small instrument. But I'm thinking, if you use a small instrument, you lose all the resolution. So I want the best resolution that I can get. Now, some people choke their aperture. So let's say you've got a 10-inch or a 12-inch daub. You can put a mask on the front of it that just has a small opening. So you can turn it into a 3 or a 4-inch scope. And maybe that'll improve things. Maybe that's one of the tests or measurements that I'll do, is use a big telescope, I'll mask it and see how the seeing changes. But resolution is going to tank when you do that. So I want the best resolution when I'm looking at double. Mark, I've not paid attention to the chat. So are there questions here that were for me, but that I haven't addressed?
No, there's not, Blake, but
Okay.
it is getting kind of late. If we can maybe do 2 more questions and then we'll wrap it up there.
Okay.
If you have a question, please unmute yourself because most everyone is muted at the time. And you unmute yourself at the, if you put your cursor to the bottom of your screen and move to the far left, you can unmute.
And Mark and Bob, do you guys have any questions as well?
They've answered mine. Thank you very much.
Yep, you've answered mine as well. Any other questions for Blake?
Nope, just want to say it was very enjoyable. Thank you very much, Blake.
Hey,
Yep,
Yes,
same here.
thank you.
you're
Our
welcome.
first international meeting, or Zoom.
Yeah, that's right.
Yeah.